Here we go. So, if you want to share the video with people, just follow me on Twitter or email me. I would be glad to share the links with you. Thanks for joining. It was nice to see that people liked a little abstract of representation and were curious what I was going to say. I will have to leave early, like right after my presentation, to catch a flight. So it's better that you either ask questions during the presentation, there will be quite some time, and or that you simply send me an email. I will repeat that probably 20 times during the presentation, but I'm really eager to receive feedback from you and what kind of questions what kind of question you can have. I'll let people see it. So, I work as a consultant for NXP Semiconductors, but I present this project in my own name. This is a project I started as an individual consultant, so it's not directly related or owned in any way by NXP. However, since my experience at NXP was really valuable to start this project and decisive, I will mention NXP a lot in these slides because, yeah, it's also a way to show you that I'm not just talking about theory, I'm really actually applying today what I'm talking about at NXP. So, let's get started. I might start explaining a few things about the title. So DITA, okay, that's quite basic. RDF, I'm going to talk about it. It's a standard format of the W3C, so that's a standard that has CSS, HTML, or XSLT. So for DITA, standard. And yeah, I will show you how DITA can be kind of enhanced and improved and interconnected, so linked with other things. So that's the meaning behind the title. So let's go back in December 2011. We are an NXP. We have, like many organizations, this kind of architecture. So we have our DITA CMS, CCMS, that publishes documents that are stored in our document repository for published documents. We have our alfresco CMS for frame maker and drawings. Yeah, product data, characteristic and stuff. PLM, so the life cycle of our products, and our website. It's there are also a few other things, but these are like the most representative. The problem we had is that, yeah, we wanted the systems to talk together. So when you were doing something in our DITA CMS, for example, we wanted to have some information about whatever was published already, or we might record information from our PLM database from other systems. We don't want to duplicate, of course. We don't want to import all our PLM to our frame maker environment. I mean, that didn't make sense, of course, to be able to read directly. So what we were doing, and I think that's kind of the common trend today, is that we enable this kind of ad hoc connections with the APIs, either that we had to develop by ourselves, or using property APIs, or yeah, even some systems such as Components have more, let's say, more standard way of sharing data. It's not the case for most of our systems. So a lot of work for maintaining every time we have to move a server because for X reasons. We had to update everything. A lot of work. So we decided that this is not the way we want to do it. It didn't look right to us. So we were looking for a solution. And because we really cherish the principle of going standard, because we want to have different, the benefits of DITA, right? You have different vendors, a lot of choice on tooling. And why? Because DITA is a standard. A lot of companies and vendors agreed on the standard, and that's why it works. So we're looking for a solution for that. At that time, basically in the DITA world, if you were looking for a reference to RDF, you had to attend Frank's cheap list presentations, because I might not have seen them all, but I remember one in Utrecht for a Dutch conference. And yeah, it presented the RDF, what kind of data model it is. I will not enter into technical details because I know that you're probably more looking for benefits, like really, okay, how can this help me? But of course, you can email me if you're interested in more detail, like you really want to know how it works. So this is kind of the birth certificate of RDF. So it stands for Resource Description Framework. So that's what it says. It's a framework to describe resources. Resources can also be called entities or things, or yeah, it can describe anything. I will show you later. It's a W3 recommendation. Recommendation is the other word for standard. Since 1999, it's been updated since then, but I just want to underline that it's not just last year. It's kind of an old thing already. Championed by Tim Berners-Lee, who is the inventor of the web. What it means is that basically Tim Berners-Lee sees it as the future of the web. Again, I will explain why later. And also, though it's not visible to us, well, unless you really pay attention, but it has been already implemented by a bunch of quite big actors. Facebook with their graph. What's it called?
Social graph.
Sorry?
Social graph.
Social graph, yeah. Yeah, something like that, something graph. Knowledge graph.
Knowledge graph, I think is.
Knowledge graph is from Google. Anyway, there's this kind of graph, so you can search, for example, show me the pictures of my friends who live in Germany, and then shows you these pictures, it's kind of magic. Well, it uses RDF at some level to answer this kind of nice questions. Google with their knowledge graph, so you see this kind of card when you're searching for Leonardo da Vinci, you might have a picture of him or a sculpture of him with some detail like his birthday and stuff like that. And that's also resolved because Google recognized that Leonardo da Vinci is a thing that is in their database and they have information about it, about him, so they show it directly to the user. And also Amazon, Volkswagen, BBC has a really cool integration, and now NXP Semiconductors. So, to explain you this in terms you can understand, there is this way of talking about the web with Web 1.0 and 3.2 and 3.0. So I think it's a good way for you to understand where we come from and where we are going to. Let's start with 1.0. So that's the web we saw in the 90s. You browse documents using href tags. At the time was really cool because it started with like internal documents. You would be able to browse documents in your organization. Then you were able to browse documents of other organizations. In the end, it became a web of documents. So you could browse documents that were located around the world without really knowing about it. You just clicked on your link, it opens a new page. Very good. Today it's like the basic. Everybody lives with that, and you don't really understand how it works, but yeah, that's how you expect it to work. Then came Web 2.0. It was called Read Write Web. There are probably a bunch of other way of calling it. The new things that you still have your documents in the middle, that didn't change and still valid today. You still have your href links. Difference is that now, well, in the 2000 more or less, not only organizations but also people were able to contribute to the web. So it was really easy. Big companies were giving the possibility to their users to contribute and have their content public. So you could share content, well, you still can of course, share content, share links, stuff, everything visible to the public. You could build this so-called web identity, like publish things on YouTube. So that was a novelty. But yeah, for this presentation, it's not really, well, it's interesting, of course, and it's an important part, but it's not really, doesn't really help understanding semantic web. And finally, so Web 3.0, semantic web. So again, we still have our documents, href links, etc. However, what's new here is that documents are connected to people and organizations. So it's not only a web of documents, it's also a web of people, organizations, and in the end, anything. So people can also connect it to organizations across each other. You can, I mean, this is a like really simplified vision, but yeah, it basically can be anything, concept, God, yeah, what you want. Also, the really important thing is that, and that's why it's called semantic web, is that these connections between things and documents and organizations and people are semantically defined. Here, okay, this is quite small. Here you have DC:author. That's come from Dublin Core. Some of you might be familiar with it because DITA reuses the terms from Dublin Core, like author here, contributor, also from Dublin Core. So these are, yeah, most of them are, you have these many vocabularies kind of standard to describe things, like Dublin Core or FOF. Yeah, FOF knows, that's what I think Facebook uses to link a person to another person, saying, yeah, this person knows this person. So it enables a lot of cool things when you think about it, because now when you have this web, instead of having just a link to browse, like we had in Web 1.0, we can browse things by just following certain properties. So you can imagine, for example, that you want to know all the person that this person knows, but who also like this organization. So here you just follow this relationship to know who these people are. It can also be much more complicated because I will expand on this idea later, but this is called a graph. So you have, for a central thing, you have multiple levels of properties, like in XML where you have trees, so you go down, up, you have property attributes, but you're kind of limiting the way you can traverse information. In SQL you have tables, which also in a way prevents you to do what you want. Here, for anything, you can have any number of properties and you can traverse the information the way you want. So you can imagine asking questions that connects this person to this person. So I want to see all the documents to which people contributed, that were published to this organization, who were, for whom were this person. Yeah, I mean, and then you can go as far as you want. So a very simple example, I mean, just to give you an idea. So yeah, that might recall a bit data. Yes?
Can you go back one and shoot us some of the other relationships? The only one, you said DC author, but we can't read any of that.
Oh, sorry, my bad. So I also use this one from Open Graph, so that's the vocabulary created by Facebook that says likes. So this person likes this organization. This I minted up an example because you can also create your own terms very easily. So this person works for this organization. This organization published these documents. So because you have this semantically, I don't know, described relationship, you can, and because you know what you're expecting, because these vocabularies are well known. Yeah, there is this kind of agreement that about what they mean. So it helps you to traverse this graph. Well, more examples later related to DITA that might be clearer. So DITA also has somehow this mechanism. It's not uncommon to read about DITA and people saying that specialization enables for more specific semantics for the elements. So here you have a map that is connected to topics. You have topic ref, and topics are connected together with xref. The DITA author, DITA map of an author to a person. So that's how it is in DITA, and you can see some similarities. You're connecting things together in the end, even if it's just DITA topics and maps. You're connecting things together. So that's why we felt on NXP that we could export this information in a way that I showed previously, connecting DITA things, so topics and maps, to other things that are not from the DITA world or from even the documentation world. So still this, and now there is this new thing. Let's imagine NXP makes cameras, in the case, but this is a camera. we have our data content, and the new thing is that because we were able to export it to this graph, with this graph method to RDF, we're able to draw a connection between our data map to products, NXP products. And because our products are also published as RDF, we can describe our product portfolio in a very accurate way, and this way asking questions that connect all these things to our data documents. So for example, here I have a product that is part of a category of product. We're also saying things about this category of product. And because we have this all part of the same graph, of the same web of links, we're able to make queries that travels all this information down to the topic. And even, I mean, I didn't detail all the data and metadata we're extracting here, but I could also show that we are extracting the links between topics and images. What else? No, we don't extract keys because we don't use keys. But we could also extract keys. So far, so good. So yeah, that was what we wanted to achieve and what we made. Because I was the data specialist. No, let's show that first. So remember the first picture? So we had these ad hoc connections. Not easy to maintain, hard to create new ones. So now instead of having ad hoc connections, most of our silos have a dialogue with this central RDF repository. So they request data to know about what's going on with the other silos, but they also push data to inform all the silos what they are doing on their own. So you have data exporting metadata, that's what I will focus on, of course, but you also publish documents who are saying, yeah, which documents are published, when they were published, also what products they are about, product data. So we don't export all the tiny characteristics of our product yet, but it's like when was this product available, who owns it in the company, where is it located in our product portfolio, because we have like a tree that describes our portfolio for people to browse it on the website. So where is it located? PLM is about product lifecycle management, FrameMaker. We're on the way to implement that to know the status of each document. And for our website, it's very convenient because now it's only one single channel that feeds it with information. Because previously, they had to fetch information for every single silo to show information on the website. Now, it uses a single channel and makes things easier for our web hosting company. I don't put it here, but we also set up customized feeds for our distributors. So these companies who sell our products, they wanted to also be able to show product information on the website and links, updated links, like fresh links about our products, fresh documents. So we also send customized feeds to them, and it's very easy to set up. So in an hour, they have their feed more or less. So our life is simpler now. Yes.
Did you also use the documents directly from XML, or is it only the published documents?
So what we do is, so I'm going to focus on that part then, I guess. So our data repository, we export, we publish our data as XHTML for our website, as PDF for certain type of document, but most of them it's just XHTML for the web. And we also publish our data documents as data. As funny as it might sound, because we want to export a kind of dumbed down version of our data content to an XML database, and it's from this XML database that we export data to this central repository. So we use so today we use
but how would you present it in there if it's only from, then you must have something that would publish your XML data in some way.
From here to here?
No, from
here
there?
to there?
Yes.
Well, our hosting company are quite demanding on the way they want to receive the data. So from the day they were receiving data from each silo, and now they are receiving exactly the same homebrew XML schema information, because that's what they know how to deal with. They know how to process it. So for them, the files they received didn't change, just that it only comes from one single place. Okay. So between here and here, what will happen is that we transform the XML in a way that really mimics the way it was done before. The difference is that now it's only from a single place. Also, maybe one concern you might have, and question is that you might have been approached by big companies that I will not name, but basically you claim that they can offer you this big central database that will solve all your problems. That's kind of a, yeah, it's been like years since you've heard that. So, well, yes, that's what, more or less what I claim. The difference here is that this is not vendor specific. I mean, this is an implementation based on a standard format, standard framework. So this could come from, actually we're using now a two-man company based in Berlin. There are two, and they're really good. But it could also be a major vendor, or it could be, yeah, it's like DITA. I mean, your CMS could come from any vendor. You would still be able to move your data around, and yeah, you're set. You don't need to do so much configuration. So that's a big difference. This is standard.
But then it's not just connections. There's also computing and conversion and everything in it.
Yeah, I don't want to enter into detail, because this thing is not just not just a bucket for your data. It does extra functionalities. So it opens. It has a. You can query it in a specific language. I will talk about that later. You can. You have RESTful APIs for those who know that. Basically, you have a URL that matches the query. So you put the URL in your browser, Firefox, and you directly receive the result as CSV or XML. It's not XML. So even anyone from the company, they're really interested in getting data, they paste that in their browser, and they get a CSV that they can open in Excel. So it solved a lot of our problems. So that's why I started this DITA RDF project on my own time, but based on the experience I had in NXP. It's made of four principal main components. What kind of time? Yeah, it's okay. So there is a model, like an ontology, vocabulary, to describe the different parts of the DITA language spec. I don't cover everything, or only what is makes sense around linking, around referencing stuff, linking to images, topics, key references. Well, you can find that here. Okay, you might not read here, but there's a URL to see what this vocabulary looks like. So here. There's a DITA Toolkit plugin that is based on PDF2. So it reuses some pre-processing from PDF2, merging. But instead of producing XSLFO, it produces RDF XML, so which is one of the serialization you can publish RDF in. And when it's finished, I'm still working on it, but when it's finished, you can right away after your transformation publish, when it's part of the transformation, you publish your data in the triple store I showed previously. In the data store you can show previously, and there will be a version a bit adapted to components, because I know how to work and might be interesting for components customers. There will be also a tutorial, so I'm really like taking you by the hand. Like you don't need to do anything or think too much. There will be a tutorial to set up your own RDF store, either locally or on the server, so that you have a place where you can store your information about the data content, and hopefully other data types in the future. And there will be Sparkle query samples. So Sparkle is very similar to SQL. It just takes into account the fact that it's not MySQL, but RDF. And there will be query samples so that when you have done all the previous steps, you have your data in your RDF store, you've made your rendition, then you can make queries. I forgot to say that, but the DITA Toolkit plugin will support specializations. So how hard you specialize data, you will still be able to make the difference between the base elements, like P, and more specialized versions of this P element will be taken into account. So if you're looking for P elements, you will get everything. But if you get only for you're only looking for your specialized version, it will only return your specialized version. Okay, that's it. Probably questions? No.
How long did this project run?
How long?
Yeah, to get this set. You're describing the current state.
Yeah.
So how long was it from when you started investigating, doing RDF?
At NXP?
Yeah.
Okay, there were several steps. So December 2011, we decided to use RDF because it was standard, because it looked good, because it supposedly performed very well. I don't have the exact timeline in mind, but we really went into production for the first time for the first set of data end of last year, beginning of this year. In between, we had to choose a vendor, like someone who would host our data in the cloud. We chose a vendor. Their whole mother company decided not to pursue the adventure, so we had to look for another vendor. But because we already had the data, we just have to move it from one bucket to the other one. But it didn't really make us lose so much time. And now we're really enjoying the benefits that I showed, like central place, no more hassle to connect silos together. I mean, our IT department is losing employees every month, I would say, so more outsourcing. So, yeah, the less we ask them, and the better we are. Yes, no?
Just quickly, the content is being copied into the central?
No, so we don't only the metadata. That is, the data content stays in the CMS. We only so we don't use my plugin at NXP. My plugin is just like learning from the experience because I wanted to propose something standard. So with the standard data toolkit, we use XQuery for those who understand what it means.
What is a typical use case in NXP on how to use this kind of paradigm?
Let's take an example. So use cases are in MFU, so one single channel for NXP.com. We also, so this customized feed for distributors, so we don't need to ask each silo to make a specific feed for each customer that might even mix data from several silos. Now we can just work here because we have the skills. We know it's central, so we can only work the feed from here without asking any silo specialist. So that's a lot of time. We don't need to involve so many people. We also were able to use tools off the shelf, open source tools, to manage part of this information, because again, it's standard. So tools off the shelf, for example, to manage our product tree. So we use a standard vocabulary to describe our product tree. So from top categories like microcontrollers or diodes down to single products with different levels of groups and categories. So we manage that now in real time. So people are, yeah, you can imagine somewhere there's this tool that connects and updates.
But I guess to make it usable for the end user, he wants to have something where you basically combine information from different sources.
That's right. So that's what we're doing in the tool I just mentioned. Oh no, translation, because you probably have these kind of challenges, so I think it's a good example to describe how it helps us. So we had a problem with translation that we need to distribute the cost of translation for each NXP divisions. So because the NXP division doesn't want to pay for the others content divisions, others division content. So what we did is that because we have information about our NXP divisions, so we have ownership information between divisions and content, so maps. No, yeah, of ownership of products, but because products are related to maps, then we know who owns the map. And so we were able to make queries based on the website view. So on the website, it's organized by this product tree. So again, microcontrollers, etc. So we're able to make queries. For example, please show me all the content that is below microcontrollers. And then you traverse the tree. You fetch the data content that is based on the product that are part of this branch. We remove data content that has been updated before the translation was published, so we remove the content that is already translated, and that gives us a nice data content package split by NXP divisions, so that they can we can do a word count per NXP divisions and build them Right. And now our Indian team is taking care of doing